In today's lesson, we will jump right into Newton's three laws of motions. Newton's first law says that any object tends to be traveling in a constant velocity or at rest until there is an outside force that acts upon it. The simplest way to explain it is that every object is lazy, like us. It resists any changes until an outside force makes it change. In order to explain this law more professionally, we have a little ball rolling demonstration. First, we will roll the ball on a flat floor, which we assume that the friction is really small and can equal to 0. We can see that the distance in every 1 second interval is the same. The second demonstration is fairly the same as the first one, but we stop the ball at one point by exerting a force on the ball. The ball stops immediately due to the force exerted on it. And in this example, we're going to demonstrate Newton's second law of motion, which states that the acceleration of an object, A, is directly proportionate to the net force, F, and inversely proportionate to the mass, M, giving us the formula force equals mass times acceleration. From this we can tell that the acceleration of an object is larger when the force acting on the object is greater and the mass of the object is smaller. In our demonstration, we're going to apply a weak force and a stronger force on an object of the same size and mass. Notice that as we apply the stronger force, the ball's acceleration is greater. However, there are other factors that might affect the acceleration of an object. In this demonstration, we're going to drop a melon and a balloon from the same height. The balloon is filled with water and has the same size as the melon, but the melon is still heavier than the balloon. We would expect the melon to land first since it's heavier, but watch what happens. Notice that both land at the same time. This is because the melon, having a larger mass, also has a greater inertia compared to the balloon. The melon does hit the ground with the same acceleration as the balloon, but with a different gravitational force acting on it. In this experiment, we are going to explain and demonstrate Newton's third law of motion, which states that for each action that occurs, there will be an equal and opposite reaction to that. What it means is that if I apply a force on an object, another force will be acting in the opposite direction of the force I applied. This is shown in the experiment. When the spring is pulled, we apply the force in the direction in which we pulled the spring. As we release the spring, the opposite reaction took place, which caused the plane to launch off the spring. Thanks to Newton's three laws of motion, we now know how each law affects an object and its reaction to it.